what we want to look at are it's the one rule that people really have struggled with, and that's to find the derivative of an inverse function. So to start off, if we have a function f of x, then on f of x there's a point xy. Well, if we call g of x the inverse of f, then we have on this point y comma x. For inverse functions, we actually just switch the x and y. So the rule ends up being that given that you find the derivative of f at x, and that becomes some value, you actually can also say that g prime of x is actually the same as 1 over f primed of x. Now, the tricky thing is that if I want to put this in terms of the same one point here, this x goes here. This x is actually not an x for the g prime. You're actually using the y value of the point from f. So to find the derivative on the inverse, you use the y value from the original point, and you take the derivative at the x value of the original point and do a reciprocal. So let me show you what that looks like. So there is a point, and we'll call this one right here f of x, and we'll call this g of x. So there is this point on f of x, 2 comma 4. 2 being the x, 4 being the y. And then we also know that f primed of 2 is 4. So what I'm doing is highlighting what's written here. The rule then says that I can find on g the derivative at 4. Oh no, sorry, wrong arrow. I can find the derivative at this 4, and it will be the same as me finding the derivative of f at the point 2 comma 4. Now, that's what's giving us the 1/4, which comes here. So what happened was the point on the curve was 2 comma 4 for f of x, but on g of x, we have the point 4 comma 2. So to find the derivative at f's y value on g, we find the derivative of f on its own x value. This will always, together, will make a point. It'll either make the xy point on f or the xy point on g. Now let's try a few examples that I have. Let's see. The first one was from AP problem set number 1, I believe. It says that part D, if g inverse is the inverse function of g. Now, up here we notice that we only are given g. So now I know I'm going to be talking about the inverse function of g. Write an equation for the line tangent. That makes me think of I need a slope using a derivative, and I need a point. You want to find the line tangent on the inverse function of g at x equal to 2. All right, so let's try to make some sense of this. So y is equal to g inverse of x. So this is now saying that g inverse of 2. Well, we don't have the inverse function in the table, we only have the g function. So I'm going to rewrite what's written there in terms of g. So g of the box would be equal to 2. So I switched their x and y values. So by using the table, I'm going to look for x value when g of x is 2. And if you notice here, g of x is 2 when x is 1. So let's rewrite again. So g of 1 is 2. What does that tell us? Let's go backwards. That tells me that g inverse of 2 is 1. So here's my point. Now I need a slope. I'm going to find my slope. Let's do it down here. On the function g inverse. So I need to use the letter y. We're going to rename our function y instead of calling it g inverse, just for notation purposes. So to find y prime, I'm going to find it at 2. And the reason I'm doing that is because I'm using the x value of the point that we found. And the derivative of y prime at 2, that'll actually be the same as me finding the reciprocal of the derivative of g at 1. Because 2 comma 1 makes the point. And so if I want to use, given that y is the inverse function, I'm going to use the original function g at the value of x equal to 1 and use that derivative to find the derivative of the inverse function of g at 2. I know this is very confusing. I'm going to use my table. G, and then the derivative at 1 is 5. So that's 1 over 5 is the slope on the g inverse function at 2. So up top, let's write the equation for a tangent line. Therefore, the equation is y minus the y of the point, which is 1, and I'm getting that from here, equals the slope, which we found was 1/5, x minus x of the point, which is 2. And I did this all on the g inverse function. So on the g inverse function, 2 comma 1 was the point, and 1/5 was the derivative of g inverse at 2. Remember that we got that from doing the reciprocal of the g derivative at 1. So I'm going to write that out one more time. So g primed of 1 is 5. On point g, 1 comma 2 makes the point. So we use 2, and we can say that g inverse, if we want to take its derivative, and I guess I'll do it this way, at 2, it'll be the same as us doing 1 over the derivative of g at 1. And that's how we got our 1/5. Okay. One more problem to try. This came from the book. F of x is equal to x to the 5th plus 2x cubed plus x minus 1. Now I'm calling g the inverse function of f. I'm telling you that f of 1 is 3. So now it's telling me to find g prime of 3. Now, you could go through attempting to find the inverse function and actually finding the g function, which will take a good amount of time. Or you could use implicit differentiation, and that would actually work. Again, taking a lot of time. But if you use the rule that we were looking at, I know that 1 comma 3 is the point on f. That means that 3 comma 1 is the point on g. So if I want to find the derivative of g at 3, then that'll be the same as me finding 1 over the derivative of f at 1. So on g, that's the x value. On f, that's the x value. Notice that together they make a point. Now, finding f primed at 1, not really that difficult considering it's a polynomial. So f primed of x is 5x to the 4th plus 6x squared plus 1. So f primed of 1 is 20. Wow, I'm about to take another derivative. Is 5 times 1 to the 4th, which is 1, plus 6 times 1 to the squared power, which is 1, plus 1 more, so that's 5, 11, 12. Therefore, coming back over here, g primed of 3 is the same as 1 over f primed of 1, and we just found that f primed of 1 is 12. That's actually the answer to our question. Hopefully this was helpful. Restating the derivative of the inverse is very confusing, and it really has to do with the fact that 1 is f's x value, but that becomes g's y value. And what you'll notice is that g's x value becomes f's y value. I always just remember, if I want to do the derivative of inverses, that these two always make a point. They're never the same value unless the point is 2 comma 2. Then both would be 2. But if it's 1 comma 3, one of them has to be 3 and one of them has to be 1.